Hello and welcome to episode 9 of Let's Make It. This week, I promise it won't be quite as long. I'm only going to show you one program tonight, and I'm going to tell you a little bit about some of my struggles this week in getting this actually to work. Wasn't anything programmatically, but I was trying to find the right parts that I thought I had. Plus, I got a couple of new things this week I'm going to talk about for future episodes, some really cool things. And possibly if I get the parts for next week, but next week's project is going to be because of another problem that I'm having. So I'm trying to solve a few issues. All right, so this week we're going to talk about randomization, like how you generate random numbers. And to do that, what I've done is I've written a program that generates a random die. Like if you would take a die and you'd throw it, and it'll generate from 1 to 6. So what I was trying to do was when we're looking at a die, I was trying to get a LED display with a little number on it, which I thought I had some laying around, and I couldn't find any. So I ended up just using last week's breadboard project and using the 6 LEDs, changing them all to red, but using basically the same breadboard configuration as last week for this program. So it's going to look kind of familiar to you. So I'm going to go look at it and we'll go walk through the breadboard configuration really quick. So let's go over to the Arduino. And you see it's not really doing anything right now. You do see it's on, the LED light right here is on. And you're going to see the 6 LEDs from what looks like last week's project, the same red, yellow, and green that I used for the stoplight project, and all the same resistors. The only thing that's really different is down at the bottom last week I had 2 switches. One represented a car waiting on one light, and one represented a car waiting on the other light. Well, now I replaced it with just one. So I basically took out the right switch and left this left switch right here pretty much as it was. I had to move the one jumper by 1 pin, but otherwise it's pretty much the same. And everything's wired exactly the same as well. So this is going to simulate a 6-dot die. And the way it works, if you want to roll the dice, you click the button. And you see it's rolling the dice. And the final result is 4 in this case. So what it was doing before that, it was simulating what happens when a die is rolled. It just keeps turning. And this is all done through random number generation. I'm going to run it again. And you see it's simulating the die rolling. I may have put too much of a pause in there, but 2 was the final result. So you see the final answer blinks 3 times. That's important to remember. We're going to see that in the code. I'm going to run it one more time. And I got 2 again. Doesn't seem very random right there, does it? I noticed this when I was running it. It didn't seem very random at some points. All right, 6 was the result at that time. So there you see 6. All right, I'm going to roll one more time. So we got 5 that time. So what I've done in this program is I've also written serial output code so you can watch what it's doing at the same time, like I did last week's one. You can see what it's doing in the process. And it's very interesting. So if you want to get the program, you download it, plug it into your Arduino. You don't got to make the breadboard or wire everything up, but you want to see what it's doing and follow the code. But what it's doing is it's generating a random number. And what it does first is it generates a random number, determine how many times the dice is going to roll. And it's going to be between 15 and 25 times that the dice is going to roll. That's why you keep seeing all these different blinking, is simulating that if you throw the dice, it doesn't always just stop on one number. It tends to roll around. So it randomly determines how many times it's going to do that. And then for each time that it does that, it randomly generates a number. When it gets to the last number, it falls on through the process and then blinks the final result 3 times. And that happens every time I press the button. So I'm going to hop over to the program now. We're going to walk through it from top to bottom. So we hop over to there. So here we are at the program. And you see at the very top my comment, and I call the program rolling the dice. And it just simulates rolling a die. It randomly determines how many times a die will spin until it lands on the final number. Each roll uses the random number generator to determine the value of each roll. And we pause each roll for the roll number times 10 plus 50 milliseconds. So the first time is going to be 60 milliseconds. Or sorry, first time will be 50 milliseconds because it's 0. Second time is 60 milliseconds. The third time would be 70 milliseconds, and then it goes up to 90 milliseconds. So you see it keeps increasing. That just simulates the die slowing down. So it spins fast in the beginning and slows down towards the end. Then when we get to the final number, we're going to blink it 3 times. And I also put in here that the code does output to the serial port. So you can see what it's doing through the entire process. And I will run through that. I'll bring up the serial port and we'll run it a couple times. And then the pinouts I'm using are basically the same as last week's project. I didn't change anything around for pin-wise or wiring-wise. So it's pins 4 through 9 for the 6 LEDs, and pin 11 is the button that I left connected. So we're going to come down here, and I'll talk about there's a resistors going to ground on the switch so the pin's not floating, and resistors for each LED as well. And then the normal stuff. All right, so we come down here, and we're going to find our pins again. So it's important to know what order these are in, and I'm going to explain how this is going to work. So we have an array here, it's LED pins, and it's just 4, 5, 6, 7, 8, and 9, the same ones we used last week. So position 0 is pin 4, position 1 is pin 5, and so on up to position 5. Remember, everything starts at 0, not at 1. So we come down here to the dice patterns, and this is basically saying here's what lights are on for each of the numbers. So I have one die on for this. I have the 2 bottom lights on for this one. I have the 2 bottom and 1 top on for this one. So you can see I'm basically doing this pattern based on what number was rolled, and the very last one being 0. So I want to explain now how these connect together. So down at the bottom, when I get to it, when I actually output the pins and turn them on or off based on what number you're sending it, I'm going to go through a loop and say for pin 4, I want it to be off. For pin 5, so let's say I rolled a 3. We usually do a 3 here. So I roll a 3, and I'm going to come up and say for rolling a 3, pin 4 should be off, pin 5 should be off, pin 6 should be on, pin 7 should be on, pin 8 should be off, and then pin 9 should be on. So you see how these relate. This position 0 relates to this position 0 in this 2-dimensional array. So when I output any of these, so I'll start at 3, I will start at position 0, and I activate pin 0 based on the 0 or 1, which turns the pin on or off. So that's something important to remember when you get to the bottom. If I didn't explain that, it wouldn't make sense what I'm doing. So we're going to walk through it when we get to the bottom again a little bit too. All right, so here I define button pin number 11. That's the button I'm going to press. And I'm going to define a variable called blank, and you'll see why in a little while, but blank basically is the 7th position, which is 6 really, because start at 0, and it's basically turning off all the pins for the dice. We come down to setup, and just make it quicker, I could have done this by individually going through the pin numbers, LED pin 0, 1, 2, 3. I create a little loop, and basically goes through all 6 pins, and turns them into outputs, and turns them off. So if you reset the Arduino, it will turn off. Now, here's where we get something new we haven't talked about before. This is called random seed. So the random generator needs something to start from to generate random numbers. So you have to set the seed. So all I did in this case is I just took analog read of pin 0 and used it as what I'm going to start the seed. This is something you have to do before you can use a random number generator. It doesn't know where to start. Otherwise, it needs like a base. I don't know, that's about the best way I can explain it, but it's something that's required, and you can put any number you want in here. I just took a number off analog pin 0, not know what the number really even is. And then I start the serial port up because I want to output to the serial console so you can see what it's doing through my code. So I come on down to the loop, and the loop is very short this week compared to last week, and all I'm going to do is look if that button pin is pressed, and if it is, I'm going to print to the serial port saying that I'm rolling the dice. And I call the routine roll the dice. And then when I come back from that routine, I delay for 1/10 of a second. That's just so it's not running wild. If you were sitting here and the button wasn't pushed, you'd be eating all the CPU. This helps give some time back to the CPU. All right, so now we're coming down to the actual function that we just called, and this function will generate a random number. Let's just walk through the actual code rather than read the comment there. But basically, we determine how many times is this dice going to roll before it stops. And like I said before, it's going to roll anywhere between 15 and 25 times before it stops. So in this case, I'm going to get back this thing called length of roll. And you see right here, I printed out in the serial port, and I'll walk through this in the code then, and you can see how that works. But what we're going to do right here is let's say length of roll was 16, one more than the lowest number. I'm going to create a loop right here that goes from 0 to 16, And as I'm going through this loop, you see the for loop right here, setting my loop variable equal to 0. And while it is less than length of roll, I want to continue this. And after each loop, I'm going to increase it by 1. So ultimately, it becomes longer than length of roll. I'm going to do another random between 0 and 6 for the value of the die. And I'm going to show what that result is on the LEDs. So I called this function called show, which we'll get to next. And then after I show it on there, I print to the serial port what that value was. Now you notice right here I'm saying result plus 1. And the reason I'm doing this is because really result 0 is equal to 1. And so for us to be able to read it in English or numerical value, we're going to make it equal to 1 because that's what the die is going to represent. So that's why I put that like that. And here is the multiplication of the waiting time. And basically, one thing is important to remember, and this is the order of calculation, is that multiplication and division happen before addition and subtraction. So in this case, I times 10 is going to be calculated first. So the first time through it's equal to 0. 0 times 10 is 0. And it's going to add 50. So it's going to delay 50 milliseconds. The second time around, I is going to be equal to 1. So it's going to be 1 times 10 plus 50, which is 60. And the third time around, it's going to be 2 times 10, so it's 20 plus 50. And the next time around, it's going to be equal to 3, so it's going to be 30 plus 50. So you see each time it comes around, the delay gets a little bit longer. And the reason you do that is it simulates the die slowing down. When you throw a die, it spins faster at first, and it gets slower as it rolls. So that's how you were simulating that. So that's it for this loop. So all we're going to do is for the length of the roll, which is in my case I said 16, we're going to generate a random number every time. We are going to show the result on the LEDs. I'm going to print the results out to tracking. I'm going to wait whatever the calculated time is, and I'm going to keep going through this loop until length of roll, or I is greater than length of roll. So say I hit 16, whenever I is equal to 16, it's going to drop out of this loop. And then I'm going to print out that the dice landed on, and I'm going to tell you what the final result was. Then we come down here and we are going to go through this loop 3 times, another loop. And I'm going to basically turn off the LEDs for 500 milliseconds or half a second, turn them back on with the final result, and then delay 500 milliseconds. And I'm going to do this 3 times. What the end result is that it'll stop blinking with the final result. So we have one more function to go through right down here, and this is show. And this is actually a very simple one with another loop. And this is where I mentioned at the top that how the arrays work together. So basically what I'm going to do is I'm going to say digital write, which we know takes a pin number and gives it either on or off with 1 or 0. So I'm going to start at 0, and which is the first pin that I defined at the top, which was pin 4. So I'm going to say pin 4 is equal to whatever the first value is of the pattern for whatever result it was. So let's say I rolled a 3. So first one's going to be 4. For LED pins going to be 4. And if I go up and we'll look at 3 again for 0. And we see that a 3 is off. So I'm going to turn pin 4 off. I'm going to go through the loop. The next pin is pin 5 because I know I put in my array up top. And I know that result 1 or array item 3 and the second pin was off. Then we're going to do it again. We're going to go to pin 6, and I know it was on. We're going to go pin 7, and it was on. And pin 8 was off, and pin 9 was on. That's how we generated the 3. So you see how they relate to each other from the array at the very top. And that is pretty much how it works. So let's go watch it run again. I'm going to go back over to the Arduino, and I'm actually going to reset it so you see that everything turns off. Of course, the camera looks better now because it's not bright anymore. That's part of the problem with LEDs. I'm going to press the button, and you're going to see it put out its different calculated numbers and then blink 3 times. So the result was 4 with that one. I'm going to roll dice again. And this time we have 1 is the result. And we're going to roll it again. You see it randomly doing everything. And the final result was 2 this time. So what I'm going to do now is go back to the computer. and I'm going to turn on the serial monitor, and I'm going to press the button. So there you see me. Let me make this a little bigger. Rolling the dice, and it's going to do 15 rolls, and it rolled a 3, a 2, a 3, a 5, a 1, a 6, a 3, a 2, a 4, a 3, a 2, a 4, a 6, a 1, and the last one was a 3. The dice landed on a 3. And if we go look at the Arduino, I have 3. So let's go back over to here, and we're going to do it again. I'm going to push the button one more time. Rolling the dice. This time it's 23 rolls. So you see much longer. I'm not going to go through them all again because you get tired of hearing me route now 6, 1, 1, 2, 3, etc. But you can see there's 23 rolls here. Let me just make sure it's 23. 23 rolls. The very last one roll was a 1. And if we go look at the Arduino, we have a 1. And if we do it one more time. This time we're rolling 23 rolls. And the dice landed on a 4. So we go back and just make sure we still have the 4. All right, that is the program for this week. Very simple. I'm only going to do one program this week. I wanted to show you a number. I was going to get the little LED digits, but like I said, I can't seem to find them. So I don't know where they are. I do know where I had some that I used a couple weeks ago for clocks, which is probably upcoming episode I'm going to work on with you as well. I actually built some recording timers, so we can put one in the studio here and one out by the the running console, and we can see how long we've been recording. So I used those in that clock that I built. So I don't have any extras apparently around. I thought I had some individual ones around. I did find some VU things. I thought that they were, but they weren't. So if I find some, maybe next week I'll just rewire this into that, and we can show you what that does too, because it'll work exactly the same way. It would basically be the same array of numbers with what pins need to be on. There's one more pin, right? There's 7 segments, so 7 segments would be one more pin than we have right now. So I have to increase the array by 1. But it would basically work exactly the same way, and it would just be an extra pin I have to wire up. Like I'd use pin 10, which I'm not using right now. And maybe if I can find some of those, I'll actually try that and show you. I know in a future episode we're going to talk about using multiple digits like that, LED segments. How you do it by saving pins, so you don't have to wire up 14 pins or 21 pins if you're using 3 digits. There's an easy way to do that, and we're going to walk through that in a future episode. So that was pretty much the project for today. Very short. I just want to teach randomization a little bit and show you how that works. And it's easy to do if you don't understand what I went through. Go out and look at the Arduino website. There's good documentation on the Arduino website for that. Now, I have a couple other things I want to talk about this week. I've gotten some fun things this week for upcoming episodes. Let me start with this. So this is a motor that I got with the intention of using to help build a robot. And that is what I'm going to build. However, I have found something better than this, and it came as well. These are actually geared kind of for what we're going to use it for. So you see a motor and you see the gearing on both sides, and they're real easy to mount. So this is what we're going to use to try to build a robot in a future project. And along with these motors also came tires that we're going to use as well. So they're very sporty looking tires. It'll be a very sporty looking robot, but you can see they actually are designed to fit with these. They actually come as a kit, and they go together. Oh, I say that and it's not working. They do go together. There they go. You can hear the motor. So these are all designed to go together. So that's a future project to look forward to, is making of a robot, which is kind of what I wanted to do with the color sensor that I haven't had a chance to get working yet as well. So that's that. And the other thing I got, which, talking about sensors, this is a pack that I got from, it's like DF Robot in China. And this is a pack of sensors. So let's go through the sensors. This is a digital white LED light module. That's not really a sensor, that's just a bright light. This is a magnetic sensor. So none of these have been opened yet, as you can see. I literally just got them, I believe yesterday or the day before. And I don't know if it's detecting a compass type magnetic or if it's just a magnetic sensor. I'm thinking it's just a magnetic sensor because I do believe I saw a compass one in here as well. Here's an analog linear temperature sensor. So this is a little bit bigger than one we had before for temperature sensing. It's kind of hard to tell. I don't know if I can show it to you on the camera. Let me stop the Arduino so you get light. You can see it's a lot bigger than the other thing we had. So haven't had a chance to play with it yet. And let's see, what else do I have in here? Vibration sensor, and you can see these are all about the same form factor, just like that. Very similar form factor. Let's see. So this is a vibration sensor. I'm kind of curious to see what it does, and how sensitive it really is. And let's keep going through the little baggie here. This is like a little toy bag. This is a capacitive touch sensor. This will be fun one to play with. You can do all kinds of neat things with touch. You can basically touch things to turn them off and on or do different functions. I can't really read through, but it looks like there's only a little area you can touch on the board itself. So it's not like you can hook it up to your lamp and do a touch lamp with it or anything like that. But that should be a fun one to play with as well. And as we're going through here, ambient light sensor, which there's a couple ways you can do this. And this is actually, as you can tell, I can tell from there, but it's the same size as the other boards. Probably bigger than what you really need for a light sensor. So I imagine the board is just for support, but that'll be a fun one to play with as well. I actually have some other light sensors we could try and play with using the analog inputs. I believe these are all digital, so these will all come back with digital information. This one is a grayscale sensor, which this would be a cool one to play with. I hope it works better than the color sensor. That's the only thing I can say, because the color sensor, I was not impressed with how well that it worked. But maybe the grayscale will work a little bit better. And let's keep going here. Digital tilt sensor. Let's see, is it mercury? It doesn't say mercury anywhere on it. No, it's not mercury. It's just a chip. So this would be a fun one to play with. Safe, no mercury. We'll see what that does. And then our last one is a digital push button, which isn't really a sensor per se. Oh, there's definitely a button in there. Again, you can see it's the exact same form factor as the other one. So this must be a common form factor for this company. And the company is called DF Robot. I'll have to put a link. It's dfrobot.com. I'll put a link somewhere in the show notes. The other thing, when I get to playing with these, so you have a lot more sensor episodes coming up. I kind of like your opinion on which one you'd like me to work with first, if you had one in particular. But that was the fun toys that I got this week. Now, I actually have some other things coming. And this is a project that if I get them for next week, I'm going to do for next week because I actually have a need for it. I'll put them back in later instead of tasting your time. We're been having a problem with our Ustream stream just dropping and don't know that it drops. And it's on a machine that's on a KVM, so we don't see the screen all the time and don't realize that it drops unless we go look at it. So I found out this week how you can check to see if the stream is live or not live programmatically. So what I am going to do is I have a Ethernet shield coming, and if it comes by next week, I'm going to write a program that will go out and check its status and build a little box that will tell me the stream's live or not live. Ultimately, I want to put it into like an on-air light, just like the old-timey on-air lights. And, that would be a kind of a cool way to, a little nostalgia, and plus you'd be able to look at it quickly and say, hey, I'm off the air. So that's the part of the ultimate goal with that. I may also try to do it with a Raspberry Pi. I have some Raspberry Pis sitting around, and I have a couple other projects for Raspberry Pis coming up as well that I can put on the show. Right now I'm kind of focusing on the Arduino, but it doesn't necessarily have to be on the Arduino. We are redoing the background and everything you see because this Zen thing was just temporary. And as part of that, we're probably going to have like 2 monitors behind us on both sides for decoration. And I kind of wanted to be able to control them with something cheap because I don't really need to run anything on them. It's more for decoration and putting images up and stuff like that. We may occasionally be able to run something to them. But the easy way to do that is to use something like a Raspberry Pi and a digital signage piece of software, something free. There's a bunch of it out there that is free, and we could just pretty much change them for the show. Each show, put the show name up there, something similar to that. Just something that's decorative more than anything. So there's a couple monitors behind me. So that's a project coming up as well. But the Raspberry Pi can also be used. It's very easily. I've actually already written things in Unix to be able to tell the status of the show up or down. as far as the live stream goes, but I haven't really messed with controlling any output from it. So far, it's pretty much just been used as a computer for the most part for me, and I've actually used them for remote control of things as well, but not in turning certain pins on. So that could be a fun project as well. I'd like to learn how to do that, and that'd be another fun one. But if the Arduino, if the Ethernet shield comes, I can do that in Arduino as well, and you can see how you can check the status or read things from the web and get statuses. The Ustream status is actually very easy to get. Took a little while to find it, but I actually did find it in some forums on a certain Ustream page of how to check the status. So I can very quickly just make one web request and get back the status. Based on the results, I can make the Arduino do something. So the fun part would be taking like an Arduino Uno, sticking it inside of a light that says on air and controlling the on air light. That's kind of what I was looking to do. And again, more fun and nostalgia, something to hang out in the studio somewhere and very quickly look and see if the stream is up or down. So that's another upcoming project, and it could be next week's project depending on if I get the parts or I don't. And if I don't, maybe I'll just do the Raspberry Pi version of it and show you that next week. So I don't know for sure what's coming up next week. But I just gave you a bunch of sensors that I have. If one of those is interesting to you and you want me to play with it first, please drop me a note. I'd love to focus on what you'd like to see as well. So coming towards the end of the show now, I want to just remind you that you can watch us live. Tonight I've had nobody in the chat room. This is the first week in 3 weeks I've had nobody in the chat room, so I have nobody to chat with. But we'd love to have you come watch us live every Tuesday night at 7 p.m. right here at techzen.tv. And when you get to techzen.tv, at the very top, there's a little thing that says live. Click on that and you can watch us live. And you can also chat with us live. So I could have live viewers on here right now. I can't really tell that because I'm not in the Ustream console, but I have nobody in the chat room to chat with. So we'd love to hear from you. And if you're watching this, not watching this live, that's just perfectly fine. The best way to get us, though, regularly is to sign up on iTunes. You know, iTunes, you get it download automatically to your device, or any podcasting or podcatcher software. Whether it doesn't matter if you're running on Android or whatever. I just appreciate you subscribing so you get automatic updates from us. If you're listening to us, this show is more geared towards visual, but you're always welcome to listen to us. We are on Stitcher Radio and a bunch of other places as well, things like Stitcher, that you can listen to us as well. We much prefer those. In this case, you probably want to watch because we're showing you visual things. This show works better for that. We'd love to get your feedback. If you go to the show page at techzen.tv/let's make it or let'smakeit.tv, either one, you can contact us via our voicemail number that's on Google Voice. And don't worry, we don't pick up that phone, so it won't scare you when we pick up. But leave us a voicemail. If you want to create a video, you can upload that video to YouTube or to anywhere that hosts videos and send us a link to it. Just don't send us the video in email because they're just too big for us to receive, and most times we just won't even get them. But so the best thing to do is send us a link to the video. Any kind of feedback you have. So if you're watching this on YouTube, subscribe to the channel. That helps us a lot to know how we're doing as far as subscribers go. You can comment there or comment on the show page as well. We do have a community, a Google community. It's brand new, still very empty, but we'd love to have you join that too if you want. You can get to that by going to techzen.tv and clicking on the community link at the very top. All right, I think that's it for this week. It was a very short one and not as much time. I'm not taking up so much time with you this week. But next week, I'm not sure what I'm doing yet, so come back and see. It's going to be a surprise. You have some ideas of what's coming up. And again, give us some feedback. We love your feedback. All right, thank you very much. See you next week.